Hi everyone, welcome back to the channel. So we are solving CBSE 2026 Maths Standard Paper Set 1 Section C, and we have solved till 28th question. Now this is the 29th question. This question is related to the circles chapter. Okay, let's see. Prove that the length of the tangents drawn from an external point to a circle are equal. So look at this. Here's the circle with O as the center. PA and PB are the tangents drawn from an external point P to the circle. So what we need to prove here is to prove PA is equals to PB. Okay, this is what we need to prove. Now we know that this is the standard theorem, right? PA will be equals to PB. Now how do we prove it? We have two options here. Let me show you the first option, that is method 1, in which we are going to use the Pythagoras theorem. Okay, so we have joined here this O to A and O to B. So OA and OB are the radii here, right? So we know that, and we have also joined O to P. So OP is the common side between these two triangles. We will write here, in this triangle, OA is perpendicular to AP, correct? So because a tangent is perpendicular to the radius through the point of contact, right? That is theorem number 1 of this chapter, circles, right? And similarly, OB is perpendicular to PB. Again, the same theorem, the tangent is perpendicular to the radius through the point of contact. So that is the theorem. Okay, so by the theorem, we know this. Now that means triangle OAP and triangle OBP are right angle triangles, right? Because both of them contains the 90-degree angle. Now they are right angle triangles. That means Pythagoras theorem can be applied. Okay, so in triangle OAP, if I am applying the Pythagoras theorem, I can write, see, 90 degrees opposite side is hypotenuse. So this side is hypotenuse. I can write here OP square is equals to OA whole square plus PA whole square, correct, using the Pythagoras theorem. Similarly, I can write in triangle OBP, again the hypotenuse is 90 degrees opposite, that is OP. That is OP whole square is equals to OB whole square plus PB whole square, correct? Now these two are the equations we are having, right? Now if you look at the left hand side, in both the equations left hand side is equal, so we can equate the right hand side also. But before that, I know that since OA is equals to OB, because they both are the radii. So this is the radius. They both are equal. So I can replace the value here or here. So by comparing, let's suppose this is first equation and let this is second equation. So comparing both, because the left hand side is equal, I can write OA square plus PA square is equals to OB square plus PB square, right? I know that OA is equals to OB, correct? So I can replace the value here. So further I can rewrite OA square plus PA square is equals to OA square plus PB whole square, right? This can be cancelled and we are left with PA square is equals to PB whole square, which in turn is giving me PA is equals to PB. Yeah, so this is the proof here. We have proved that PA is equals to PB, that is length of the tangents from this external point P to a circle are equal. Okay, so that is the first way. What is the second way? In second way, we are going to use the Arches congruency criteria. So let me show you that also. Let's see. This is the OR method. Now, in triangle OAP and triangle OBP, I know that this OA is perpendicular to PA and OB is perpendicular to PB. I know this by the theorem 1. Okay. So we know that in both the triangles, theorem 1 means the tangent at any point is perpendicular to the radius to the point of contact. That is theorem number 1 of this chapter, circle. Okay. Now in these two triangles, I know that one angle is 90 degree. Okay. So I can write here angle OAP is equals to angle OBP is equals to 90 degree. Right. Then we know that OA is equals to OB, that is equals to the radius. Now right angle, one side, and what is remaining? The hypotenuse, right? So we know that OP is equals to OP, that is the hypotenuse, and it is the common and equal also. So by the RHS criteria, by the RHS congruency criteria, I can write triangle OAP is congruent with triangle OBP. And if that is the case, I can write therefore AP is equals to BP here, okay, which is nothing but PA is equals to PB by corresponding parts of congruent triangles, that is by CBSE. So this is another way that you can prove this theorem. Okay, I hope it is clear. Right? Moving on to the next question. Again, a very good question from the chapter Circles. Two tangents TP and TQ are drawn to a circle with center O from an external point. Prove that angle PTQ that is equals to angle twice of angle OPQ. Okay. So let's see the proof here. We know that since OP is perpendicular to TP by theorem, again the tangent is perpendicular to the radius to the point of contact. So OP is perpendicular to PT. That means angle OPT is equals to 90 degrees. Okay, that much we have established. Now let's see. Okay, yes. And look at this here. We know that the length of tangents from an external point to a circle is equal. So we know that TP is equals to TQ. If that is the case, we can say that this angle is equals to this angle, that is angle TPQ is equals to angle TQP, right? Angles opposite to the equal sides are also equal angles. That is your isosceles triangle theorem, right? So that much also we know. Now let's look at this again. Let's come back here. Angle OPT can be written as angle OPQ, that is this small angle here, this small angle here, this small angle, that is angle OPQ plus angle TPQ, right? This angle, that is complete angle OPT. So let me write that here, OPQ plus angle TPQ, that is equals to 90 degrees. I can rewrite the equation as TPQ is equals to 90 minus angle OPQ, correct? Now, I know one more thing, that TPQ is equals to TQP, okay? So now let's focus on this triangle, that is triangle TPQ. In triangle TPQ, I can write angle TPQ plus angle TQP plus this angle, that is angle O, uh, this angle PTQ. Okay, so that is angle PTQ because it is shown here also, and this is what we want to prove. So that is why we are writing like this. That is equals to 180 degrees. How? Angle sum property of a triangle. Now I know that these two are equal angles, so I can write it as twice of angle TPQ plus angle PTQ is equals to 180 degrees. Correct? Let me name it as equation number 1. Okay, let's continue. This TPQ can be written as from equation number 1 as 90 degrees minus angle OPQ is plus angle PTQ is equals to 180 degrees. Let's continue this. This is again 180 degrees minus twice of angle OPQ plus angle PTQ is equals to 180 degrees. Clearly these two are cancelled and we are left with angle PTQ is equals to twice of angle OPQ. Okay, and this was the proof. Alright, hence proof. So both the questions of circles we have solved, that is question number 29A part and question number 29B part. Okay, so that will be all for this video. We'll continue from the next question in the upcoming videos. Please like, share and subscribe the channel to receive the notifications. And if you have any doubt, you can ask me in the comment section. Okay, thank you.